Welcome to another video. So today I'll be looking at an algebraic problem and I'll be teaching you how to solve it. So this problem consists of 4 original equations and you're supposed to find out the value of the final statement using the 4 equations. So this problem revolves around simultaneous equations and solving them using subject distribution. So here goes. Ax plus by equals to 5, the first of the original equation. Ax squared plus by squared equals 10. Ax cubed plus by cubed equals 50. Finally, ax to the power 4 plus by to the power 4 equals to 130. So what is the value of 113 times x plus y minus xy minus 120 times a plus b? So that's the value that we are looking for. So how do we solve this? So first of all, you need to take the subject, one of the subject in the problem, and you have to multiply it to one of the equations. So we're going to start off with multiplying the subject x plus y to the second equation. So in this problem, you need to find a total of 3 subjects: the sum of x and y, the product of x and y, and the sum of a and b. So we'll multiply the first subject, the sum of x and y, and multiply it to ax squared plus by squared, the second equation, throughout. So we expand it, it becomes ax cubed plus ax squared y plus by squared x plus by cubed, and that is 10 times x plus y. We already know from the third original equation that x cubed plus by cubed equals to 50. So 50 plus ax squared y plus by squared x equals to 10 times x plus y. Now, on the left hand side of the equation, we take the second and third terms and factorize out the common terms and leave the other terms in the parentheses. So 50 plus, we factorize xy, which are the common terms in both the second and which are the common variables in both the second and third terms. And you factorize it out from the parentheses, so it is 50 plus xy times ax plus by, and that is equals to 10 times x plus y, which is constant. Now we already know that ax plus by in the original equation equals to 5. So 50 plus 5xy equals to 10 times x plus y. So we have the first of the simultaneous equations. Now to get one more of these simultaneous equations featuring the sum of x and y and the product of x and y, so that we can substitute and solve it, we'll take the cubic equation. And we'll multiply the same subject x plus y to both sides. So x plus y times ax cubed plus by cubed equals to 50 times x plus y. So since you multiply the subject throughout the equation, you expand it. X to the power 4 plus ax cubed y plus by cubed x plus by to the power 4 equals to 50 times x plus y. As you see, in both cases, I haven't removed the parenthesis on the right hand side. For example, 10 times x plus y, I didn't write it as 10x plus 10y, and here in the 50 times 50 times x plus y. I also didn't write it as 50x plus 50y. I left it as a factorized form. So, but we already know that ax to the power 4 plus by to the power 4 is 130. So we substitute that and we get 130 plus ax cubed y plus by cubed x equals 50 times x plus y. Now, again, similar to the first part, we factorize out common terms, common variables from the second and third terms. So 130 plus, you factorize out xy in this case as well, 130 plus xy times ax cubed plus by cubed, and it's still equals to 50 times x plus y. Similar to the first part, we can also substitute ax squared plus by squared as 10. So 130 plus 10xy equals to 50 times x plus y. So now we have two distinct simultaneous equations, or there are two sets of unknowns, the sum of x and y and the product of x and y. We'll have to use multiplication throughout the equation to solve these two simultaneous equations. So the first one is 130 plus 10xy equals to 50 times x plus y. The second equation is 50 plus 5xy equals to 10 times x plus y. So we'd want to solve x plus y first. So to make it to make the term x, y the same, you multiply by 2 throughout equation 2. So it becomes 100 plus 10xy equals to 20 times x plus y. And we have the first equation of 130 plus 10xy equals to 50 times x plus y. Now, if we subtract both equations, we'll get 130 minus 100 equals to 50 times x plus y minus 20 times x plus y. And the 10xy's on both equations will just cancel out. So it is 30 equals to 30 times x plus y. You divide 30 by both sides and x plus y equals to 1. So we've solved for the first subject in the problem statement. So we have two more subjects, the product of x and y and the sum of a and b. So we already know that x plus y equals to 1. So we take the original equation, 130 plus 10xy equals to 50. We have to do some substitution here. So we substitute x plus y as 1. So 50 times 1 is still 50. So 130 plus 10xy equals to 50. Now we bring the 130 to the right hand side and it becomes negative 130. So 10xy equals to 50 minus 130, which is negative 80. Divide 10 by both sides and you'll get product of x and y, which is negative 8. So with some simple substitutions, we have also figured out the second subject of the question, and we are getting closer to solving and figuring out the value of the final problem statement. To find the sum of a and b is the most complicated part in this algebraic problem, but it is not so hard. We also need to use substitution and other factorization methods to solve for a plus b. So we take the first ever original equation, ax plus by equals to 5. You multiply by the same subject, x plus y, throughout the equation. So if you expand it, it becomes ax square plus axy plus byx plus by square equals to 5 times x plus y. Now we already know that ax square plus by square equals 10. So we substitute that in. And now we factorize out similar variables from the second and third term. So axy plus byx. The similar terms are the product of x and y, which is the which is already the subject that we have figured out. So how this works is that in the previous ones we used the original equations of cubes to the power of 4 and squares. So it will leave x square, y square, x cube, y cube behind in the parentheses. But in this case, since the x and y terms are in the lowest, simplest forms without any powers, they can be factorized out without any of x and y left behind in the parentheses. So 10 plus xy times a plus b equals 5 times x plus y. We already know that x plus y is 1 and x times y equals negative 8. So 10 plus negative 8 times a plus b equals to 5, which is 5 times 1 equals to 5. So we bring the 8 times a plus b to the right hand side, which becomes positive, and you bring the 5 to the left hand side, which becomes negative. 10 minus 5 is 5. So 8 times a plus b equals to 5. A plus b is then 5 over 8 as you divide 8 to both sides. Now we've figured out the three subjects: x plus y equals to 1, x times y equals to negative 8, and a plus b equals to 5 over 8. So now we can solve the original problem statement in the question. So the original problem statement is 13 times x plus y minus xy minus 120 times a plus b. So x plus y, we already know, is 1. So, and the product of x and y is negative 8. So the two subjects subtracted together becomes 9. So 13 times 9 equals to 117. And minus 120 times 5 over 8, which is 75. And 117 minus 75 equals 42. The final answer is 42. Thank you. I hope you enjoyed the video. This concept revolves around heavy substitution and a little bit of factorization to find out previous equations that fit into the derived equations. Simultaneous equations are necessary in solving this question, as they help to cancel out terms and derive one subject using two scenarios of both equations. So thank you. I hope you liked the video. Please like this video, subscribe to my channel, and share this video with others. Thank you.